My name is Robert Shroll. I'm the Senior Manager of Business Development with RightScale. Presenting along with me today is Matt Wise. He's a Senior Systems Architect from Nextdoor. Matt's got over 12 years of experience with a variety of different data center and cloud environments with a heavy focus on automation, reliability, and systems performance. Currently is at Nextdoor.com and is the primary architect for production and development cloud environments serving thousands of Nextdoor.com private neighborhoods. So we're really excited to have Matt here with us today. We're going to go over this early part of the presentation introduction. I encourage your questions and things. This is meant as a technical and discussion session. Learn from an actual customer example, someone that's working with Puppet and with RightScale, and to answer any questions and things you might have about what you're doing today. Does everyone understand what we're going to go through today? Okay, great. So Puppet and RightScale, of course, Puppet, of course, is the primary developer of the Puppet system. It does license, of course, a commercial version of Puppet Enterprise, and of course provides support, training, certification, and a community for sharing. So if you're here, you're aware, probably pretty well aware what Puppet is and how they work and so on, but also know, of course, that Puppet can be used and is being used today by several of our customers with the RightScale platform. There, of course, are the Puppet Enterprise server templates, and we're currently working on those, and those are in development. I don't have a date or anything to release or talk about along with that. There are some pretty exciting customers, of course, that are using Puppet and RightScale. Coupa, which, of course, is a purchasing and procurement company. EA with their Playfish. Some of their great games, of course, are Pet Society, Restaurant City, FIFA Superstars, and Madden NFL, Zynga, and, of course, the great folks here at Nextdoor that are here today. At the end of the presentation, I have about 10 slides altogether, so I really want to make sure that we've covered the detail, but I want to get into some actual examples and some discussion and Q&A. So that's really the purpose of the presentation, since you're all here and well aware of Puppet. Why do you want to use Puppet? Well, first of all, you want to make sure that you've got the ability to do simple OS abstraction. You want to make sure that you have the same language to help manage your different resources across your different operating systems, so that you don't have to have all that confusion. It's in one place. Modularity, the ability to use the Puppet Module Forge with over 375 public modules to use. Executable documentation, and when we spoke with, and I've dealt with the folks directly at Puppet, the great thing that they're hearing from a compliance perspective is that their documentation is their executable application. And the great thing about that is the fact that it's all in one. So I don't have to go back and document what I've done. We'll take a look at an example manifest in just a moment, and you'll be able to see exactly what I mean by that, from the very simplest of terms, you can come back and very quickly understand where things are from a perspective. Its infrastructure as code, the ability to use external repositories to store and version your manifest, and we'll show some examples of that. But the power, of course, with the Puppet and the RightScale system is to get below the management platform level of RightScale and now be able to dig into the configuration and the details and things that you need to really get to the level you're working with. So some Puppet constructs, some basic domain-specific language that are used. Of course, there's manifests, modules, and nodes. So pretty standard model for model-driven configuration, and just so you know, these slides and things from a documentation perspective are going to be posted and the session's being recorded, so any type of notes and things that you want to follow up on, make sure, of course, you go to rightscale.com and you'll be able to reference this later. The model-driven configuration basically follows the ability to define, simulate, enforce, and report. And of course, very cyclical process within the configuration level at the Puppet place, okay, without having to worry about what you're doing in RightScale, but the ability to work with those two together is what's super powerful. Factor, of course, is in the client-server model, pulls the node to understand the state. The master develops a catalog of how that node should configure, and then the node executes the catalog. So it's a very cyclical process here. Your node, your master, your facts, catalog, and report working together, with the report collecting all that data for the ability to understand what's happened. Do you want to talk about this just a little bit at all, or is this? And then one more thing, like we talked about, from a documentation perspective, when you go and take a look at an example manifest from your Postgres SQL Server class, the main package, and your configuration file, you'll notice how easy it is to be able to read and interpret what you're looking at from a configuration perspective. The very simplest of terms, you'll be able to go back and take a look at exactly how is something configured, how is it set up, and what did I actually have set. And we were talking about this the other day, I think, with some of your error trapping, looking at how something was behaving and the errors that might be happening, how easy it is to go back and take a look at this. You want to mention about that just a little bit?
Well, I mean, I think you kind of hit the nail on the head, which is, this is it's very readable code.
Right.
It's not writing a bash script that can be very complicated or and hard for a a non-technical person to read. I think this is the kind of code that you could quite literally print this out, show it to someone who's not hugely technical, and if they read it line by line, it makes some amount of sense. It means that the documentation is really built in, and you don't have to do as much work.
So from an audit perspective, or somebody wants to know, is like, how did we have this problem? And you're going to get that when some type of a major error happens, and your code may have been completely done correct, your configuration may have done completely correctly, but something has happened as a result of that incorrect configuration. And somebody wants to go, what exactly happened? Can you show me where was this done and what went wrong? That's what you're kind of talking about from an ability to quickly interpret and understand it. Is that right?
Yeah, that as well as the ability for somebody else to understand your infrastructure. Mm-hmm. So, you become less of a single point of failure.
Right.
If I go away, somebody else can read the code and they know exactly how we build our database servers or exactly how we build our web servers. And it's not, how did I build a web server 6 months ago? Does that still apply? This is the live code that runs to maintain our web servers currently today.
Okay, great. So RightScale with Puppet, I think it's important to kind of talk about how do the two things work together. Just to understand, and kind of broke it into 4 pieces from a cloud configuration perspective, exactly how would you do this with RightScale? So the ability to provision and port your Puppet configurations across your public and your private clouds with your server templates. So the ability to do this in more than one cloud, in more than one place, and use the RightScale management platform to do that. So the two are very complementary to each other. And I think that that's pretty important, both for folks that are here and folks that might be listening to this later. They work very nicely together, and they have specific roles, okay? Deployments, the ability to manage your Puppet configured servers, and of course in logical clusters. The ability, of course, to manage with RightScale your access and security, your usage and your audits, everything that would go there. And the ability to auto-scale using Puppet to reduce your configurations is important also. Do you want to talk about that just a little bit from an auto-scaling perspective?
We leverage quite a bit of auto-scaling at Nextdoor. We don't do it in all of our infrastructure, but we do it in several key areas. And one of the tricky things with auto-scaling is making sure that the nodes you boot up today are configured in the same way as the nodes you booted up last week, or vice versa. That if I shut down all my nodes and I boot them up, but I've made a configuration change, that they get that new configuration change. And even, of course, I booted up 5 new nodes, but I had 5 old nodes running. Are they in the same state? Are they running the same configuration? And so by using Puppet rather than a baked-in AMI image, we're able to do that pretty well.
So be able to trace back to the previous nodes that were spawned before, go back and make sure that they're caught up from a configuration
We know that they already are caught up. That's the
right.
real key, is we know that the nodes that are going to boot right now are going to get the exact same configuration that's currently running on the nodes that have been servicing requests. We never worry that they're going to be in a different state. They're always the same.
Again, which is better from where's the best place to put the activities in Puppet or RightScale based on the question he was asking?
So the way that I look at it is that the RightScale write scripts are great for getting my instance started up and running. I use them to bootstrap the key parts of our infrastructure. They install Puppet. They install things that are cloud specific for us. So if we're going to mount some EBS volumes, or if we're going to register a host with an ELB load balancer, those are great things to do once, and you do them on boot up or on shutdown. The RightScale scripts are great for that. For us, Puppet allows us to maintain the configured state of our machines going forward. So we use it for installing all of our applications, configuring where logs are sent today versus tomorrow, where we send logs. It's really an ongoing configuration as opposed to the bootstrap process. So that's the way I see the separation.
And I think it kind of answered a little bit with the graphic that we had on the screen here next, which just kind of shows the division or the complementary nature from the server templates and Puppet. So write scripts, of course, being used for the standard activities, for the backup, log rotation, and more, but the Puppet really gets down to the configuration level. Okay, all right, great. So how can you get started with something like this? It's very easy to do, and not only have I got some simple steps laid out here, of course, on the screen and the presentation at the end, there is a reference link that's shown on the RightScale website that gets into the detail about exactly what happens behind these 5 steps. So that I want you to know that you've got the support and resources and things to understand exactly how to handle the integration between RightScale and Puppet. The ability for you, of course, to go out today with the RightScale platform and create a Puppet master and a Puppet client server template. Get your deployment going, create that deployment, launch it. Once your master is set, launch your server using the Puppet client master server template. And then, of course, you've got your Puppet master client environment now running to be monitored and scaled as a result. Continuous deployment and the ability to manage it with Puppet.
It's a great question because we're struggling with that ourselves. And I think a lot of people do. I've seen environments where people leverage Puppet to actually do their code deployments. Currently in our environment we are, as of last week, but we're looking at other methods. And the reason is that Puppet is great at maintaining existing state on a machine. You can model things and say, make this configuration file change only after you've installed this package, only after you've created this directory, only after you've created this user. But it's very hard to model the steps that your application may need for deployment. Some applications are real simple. Download a tarball, untar it, restart the web server. You can do that fairly easily in Puppet, and that's kind of where we stand right now at Nextdoor. Actually, is our code base is relatively simple for doing that kind of process for the upgrades, and so Puppet actually does that. In our case, we can log into a node, make a change to a configuration file that will define a new version of the application, and when you run Puppet again, it will go download that version of the application, install it, and trigger the appropriate services to restart. If we have a more complex model, maybe a model where you have to do certain servers in one order, and then maybe you have to update a database or run some other process, that gets more complex. And I think that at that point, I wouldn't actually say Puppet's ideal for that. Other tools like Rundeck or even the operational scripts in RightScale could probably be leveraged for that a little better than Puppet. But the question was, what are we using Puppet for if we're not using it for binary deployment? Everything. So from the start of booting up a blank Linux box that has a host name and that's it, to that box being fully supported in our environment. Now, that's a whole handful of different things in our case. We do DNS registration, so nodes self-register themselves in our DNS system so that we can get to them. We install unique monitoring scripts that interact with the collectD system that RightScale has, and we do those in a programmatic way where if I tell the system that it's going to get Apache installed on it, it will actually get Apache. It will see if collectD is installed, and if collectD is installed, it will also install a module for monitoring Apache on that server and then reporting the log data all the way back to RightScale. We also use it for configuring where syslog logs go, where we have other statistics generation software. We run Apache Zookeeper, and so we have nodes that self-register them with Zookeeper so that they can offer services to the various components in our network. It's actually, when you start looking at all the little things you do to a server, you may set it so that root emails go to your ops team so that they can pay attention to cron tab failures. You may have, you may want to adjust the log rotation configurations for Apache, rotate every day instead of rotating every week. When you start doing all of that in Puppet, it makes life really easy to make sure that your entire infrastructure is the same everywhere. And then it's changeable. If you do that in a RightScale script on boot up, and then you want to make a change to that, you have to go run that write script everywhere. But if you do that in Puppet, you make one change, run this cron tab hourly instead of daily, it just gets deployed out to all your systems so that you always know that they're in sync.
Let's go through just some of the examples. You kind of provided kind of like a step process as we go through both server templates and launching the nodes and things, and why don't kind of walk through that as we talked about from earlier.
Sure. So, at the end of the day, what we're here to talk about is how to get Puppet to really integrate well with RightScale. installing Puppet by hand, if you go and you read all of the documentation out there, it talks about doing things in a very manual, one step at a time process that is not easy to automate. And so I wanted to kind of walk through how we do it at Nextdoor, what's working for us right now. I think most of us have seen the RightScale interface in terms of launching machines. We have, a handful of server templates here. What you'll notice is that there's not very many of them. We only have 4, and really, we only need 3. One of them is there just because it has some unique monitoring attributes. When we go to launch a machine, we pick one server template, development in this case. We fill in a little bit of information, typical process. I'm going to call it dev MYs. I'm going to pick the cloud that I want to, the multi-cloud image that I want to launch it on. Pick a few security groups. I'm cheap, so I want to pay for spot pricing right now. I don't care if my machine disappears because it's rebuildable. Standard process there, nothing crazy. Here's where we have a little bit of our custom logic. And this is really, for me, where RightScale makes a big win in our environment. We could build some of this on our own, pushing custom user data through the Amazon API and stuff. But being able to build a web interface that gets the inputs that we care about and is human readable and easy for just about anybody to log in and update and make changes to as they want to launch machines is important. So when we launch a machine, there's 3 different things going on here. We care potentially that there's a load balancer we might want to connect to, and as I mentioned earlier, we don't do that with Puppet. We do that as part of RightScale and part of the Right scripts because it's something that's cloud specific. It's not something that we would port into our internal data center because we're not going to have any LB. Same thing with storage. The storage is Amazon specific. It's not something that we would want to manage with Puppet. Puppet would not be a great tool to continually check if a volume was the right RAID array or something. It doesn't really make sense in that model. So we do those things with typical RightScale scripts. But when we want to launch the node and we want to give it unique, important Puppet configuration, we have basically three options. They're not in the right order here, but that's okay. The most important one is the middle one, the base class. So this is what I think you were asking me about earlier, which was as opposed to a node classifier where the name matters, where dev MYs was what defined that I'm booting up a dev machine. We instead do that with hard-coded class names. And so we can come in here and we can type in the name of the class we want. And the reason that we do that is we decouple the host name from what it's doing. It allows me to boot up a new web server with a unique name for testing for an hour without having to go in and edit the Puppet code and go, oh, by the way, also my is www is also a web server. It keeps those things separate. The other options we have here are additional facts, and so we have a list of space separated key value pairs, and these are any data that we might need for that Puppet class. So if we were defining web server and we wanted to tell it to go to a particular database for its service, we might say DB equals and a host name for the database, or in a more real example for us, we define the version of the software that machine boots up. So we might say Nextdoor version 1.2, and it'll boot up and download the 1.2 version of the software. And then the last part there is the Puppet environment, which just is kind of an internal thing for us, for the ops team itself, to be able to test Puppet code without pushing it to production. So it allows me to define new node types, test them out in testing, and then promote them to production after we know that they're working well and that they're not going to impact other things negatively. And what this is really doing here with these 3 fields is on boot up, our write script writes these data fields into a configuration file on the system. And so we have a small plugin in Puppet that reads this configuration file. And it's a plugin for Factor, which you mentioned earlier, that allows us to create new custom facts that are sent to our Puppet master so that the Puppet Master can feed back the appropriate data. So the Puppet Master gets a node coming in, and that node says, I'm dev M Wise, and I'd really like to be a database. And, and here's a few pieces of information you need. Please compile me my configuration and then give it back. So that's kind of what we're doing here. We run this once on boot up. We generally don't rerun this, but we could. There's nothing prevents you from using the RightScale scripts to change it here and then run the script on the server and update it. How do we handle node authorization? This is something that I've struggled with on and off for a little while, and I've had long discussions with RightScale about what the best way to do this is. For people who don't know, when you boot up a Puppet client and you say, connect to my Puppet Master, get me a config, the Puppet Master will not generally automatically sign the certificate. If you have that turned on, I hope you're in a private data center where things are secure. So what you do in all of the documentation that you read says, okay, manually go over to your Puppet server, sign the certificate, and then rerun Puppet on the client node. Obviously, that doesn't work with auto-scaling. It doesn't work really well in the cloud model at all. So what we do is Puppet has a REST API that you can call to do certificate commands. You can get a certificate, you can submit a certificate, you can sign a certificate that's already waiting to be signed. We have uploaded a certificate into RightScale that we pre-generated, and we use that as a credential. And it's hidden here. It's under the advanced tab, which we can't click on because it's not real. But the machine boots up, and in the script, trying to make sure I get the order right. We run Puppet, we hit the Puppet server, it submits its CSR and says, please sign this. And the Puppet server doesn't sign it automatically. Then we actually make a curl command to go to that server and ask for it to be signed. And in our Apache config on the Puppet Master, we basically say, this particular SSL certificate has authorization to sign. And then as soon as that client has signed its certificate, it deletes the local copy of the key pair it had downloaded. I had done it different ways in the past. I built a much more complex system at one point that relied on short-lived passwords and simple DB and some other infrastructure, and it worked, but it was a little overly complex. It's in the credential system in RightScale. So it's part of the script knows to create the local private key and cert file, and it knows to get that from a credential. That way our end users don't see the real credentials, but they're available.
So it sounds like a very useful connection, and the power of being able to use both the platforms very closely together like that. So you're leveraging RightScale for the right part, and you're using Puppet where you need to.
Yeah, and I have looked at doing this in the past with pure Amazon without RightScale involved, and one of the issues is that with Amazon, the user data that is supplied is there forever. It's there for the lifetime of that server. So anybody who logs into that machine can get what the user data was that was given to that machine on boot up. So you can't pass long-lived private information there. That was actually one of the initial reasons we did it with this, short-lived password that was dynamically generated. But once we had moved completely into RightScale, we didn't need to do that anymore.
Other questions? Okay, let's keep going.
All right, so this is just a couple of screen grabs of that machine booting up. I really did boot that machine. So it took about, 10 minutes or so to boot up. One of the caveats to running Puppet on boot up is that it takes longer. So your machines don't boot up in 5 minutes. Sometimes we have certain manifests that take 30 minutes to run from start to finish.
So have you accounted for that in some of your scaling rules and things as well, based on that? Okay, so you've made some adjustments and things based on that. Yeah,
certain auto-scaling config options are tuned because of that. We know that it's going to take a while to get a new machine booted up. We actually use the schedule in the arrays for periods of the day where we know that we're going to need these machines because it takes them a little while to boot up.
Okay.
And we're a startup, and so we want to be able to shut these down and save cash whenever we can.
Sure.
So what you'll see here on the left is just that machine is booted up. You'll see, a custom message of the day script that Puppet wrote and will continue to update, as things change on the machine. You can see that it registered a DNS name that we had given it. And one thing to take away here is that we don't trust the DNS name that a user supplies to be unique. So I didn't write the DNS name as dev.mys and that's it. I wrote it as dev.mys and the instance ID. And we do that for a couple of reasons. The most important is that Puppet certificates are hostname based. And so you can't boot up two machines, have them use different certificates but have the same name. It'll fail. So we always make sure that the host name is unique, and then we allow our users to register CNAMEs when they have a one-off machine that they want to be able to have an easier time getting to. On the right, you'll see that we're looking at a Etsy puppet.facts file. So this is what I was talking about earlier, that we built our own simple, key value file. It's not very complex, but the factor plugin allows these to become real variables that are leverageable in Puppet. So in our Puppet manifests, I can leverage the unique CNAME variable and say, if that's there, go ahead and register this DNS name. And so that's what allows us to do things right now, like launch our application specifically with specific versions of the code, and we define it in there. So when we do like a software release, we'll go in to across all of our nodes. We'll edit the version of the software that we're running. We'll rerun Puppet, and then Puppet will go and download the software and deploy it and restart the appropriate services.
So I think some important takeaways, like you said, you've got limited server templates that you've been needing to use or have developed. You've been getting some great experiences with it. You're using and leveraging both of the platforms for the things that they were exactly designed for, but they are very complementary. So RightScale from a cloud-specific and RightScale-specific values, and everything else you're moving into Puppet. And the two are working very nicely together. It sounds like you've got some great examples and things of that. And it's in production every day with what you're doing at Nextdoor.
Yep.
Yeah. Okay. And I think you mentioned the recycling of the host name thing from before. So while we had it as a point to make sure it gets captured in the presentation, I think we talked about that a little bit earlier.
Yeah.
Okay, great. So I'll put a little plug in for you here also at the end. And want to remind everybody that there are some surveys on your chairs. If you could take a few moments to fill those out, they're very valuable for us from an understanding of what you got out of the session, any things that we can do to improve in the future. Matt, if you want, we'll pop over just for a quick second.
For anyone who hasn't seen what we do, it's a private social network, familiar to people who've used Facebook, but it's geographically bounded. So these are the people who live near you, near your homes, near your apartments. These are the people who you probably don't really interact with, but might want to be able to and feel awkward about doing it in person. So this is a private network where you guys, you can talk to your neighbors and you can talk to them about things that matter in your neighborhood, and it's all completely private. It's not publicly searchable on the internet. It's not, it's just your neighborhood.
So it's been pretty interesting. I went and actually did this a couple weeks ago and got this set up. I've had a great experience with it. It was kind of fun because, as you know, like you were talking about, being able to better connect with the people that live right around you. We moved into a relatively new neighborhood and thought it would be kind of fun to do this. There was a great newspaper article that was about Nextdoor from the city of Goleta that had actually done this at the city level, and then had neighbors actually join up, and there was a great story about some of those interactions that had happened that before, besides posting the lost kitten on the telephone pole down the corner, no one knew what was happening in the neighborhood, or there's a burglary or things like that. So I said, hey, why don't I do that in my neighborhood? I exactly did, kind of very quickly. It rubber banded a neighborhood. You guys allowed the easy ability to add folks, whether I knew them by email or by postcard or other verification. I've already started to get people already responding, and we're going to do the 4th of July parade in town in a couple weeks, and somebody already said, can't wait to meet you there. So that's pretty cool.
It's actually funny. Last night we were out to dinner, and I got a text message from my wife. Our dog had gotten out 3 times, actually, 3 times in one day.
Okay.
And 2 of those times, she was found by a neighbor, and the neighbor had let us know through Nextdoor because they didn't have our cell phone numbers. So they were able to send us a message and say, we found your dog, we put it back in your yard. Thanks. So, 2 times it went through Nextdoor, and then once the neighbor actually knew our cell phone number and told us, but it was a busy day for her.
Right. Okay. So one last piece. Oh, sorry, question. You got it. All right. Question was around workflow and where's the human interaction points at each of these steps?
Yeah. So let me take a step back and talk about, I think, three areas of a system. You have, in this system, you have the act of launching a machine, the act of defining it ahead of time. What do I want to boot up? And we leverage, obviously, we leverage the RightScale input screen for that primarily. We do that by hand on most of our one-off machines. So if I want to define a new, another database slave, I know that I want to define a database slave. It's the kind of thing that doesn't happen automatically in the middle of the night. You know, it's something we know we're going to do. And we'll go in and it's generally me because we're a small startup, but it can be anybody in our operations or engineering team can log in. They can clone an existing machine if we're just going to add another one of those machines, or they can define a new machine through that input screen and through the server template. And the server templates don't change almost ever, which is makes our lives pretty easy, and we don't have to manage a whole bunch of server templates or any complex differences between server templates. The next part of a machine's boot up is actually getting it ready for configuration and for all of the applications that you're going to put on it. And we generally know what those types of configuration changes to a machine are going to be ahead of time. So what do I mean by that? If I'm going to make a web server, I know that for our code to run, we're going to have to install a certain version of Python, a certain version of Apache. We're going to have to turn on some monitoring pieces here and there. And these things are all pre-programmed in Puppet. So they are, they're manifests that say this web server gets Apache and it gets the monitoring daemon and it gets our database connector, and it gets a handful of other things. And those are all predefined, we try not to change them very often. Once we've defined a machine type, we generally try to leave it alone. There's kind of a third bit.
Right. So is that in Puppet or is that in...
This is actual Puppet code, and these are the manifests that if we go
Go
back to that other slide.
Right there?
Yeah, so that's this code here. And I mean, this is a very simple version, but it allows us to say here's a Postgres server. When we want to get this running, it's going to run through these steps. And this is something that I don't like about this example. Not your fault. But you'll notice that it's got sort of some configuration lines up at the top. The PGHBA lines. To me, that's configuration state. It's a little different than the act of preparing a machine for being a Postgres server, and that's more of something that might change on a somewhat regular basis. We might change the number of the users we allow to log into the database on an ongoing operational way, and we don't really want to be making Puppet code changes just because we want to add another user to our database. That's kind of a different model. So there's kind of a third part of this that we didn't talk about, and if everyone has to end up dealing with it in some way, which is the data. It's operational data as opposed to state data. So it's having Puppet being able to go out somewhere and get a list of database users that you're going to allow to connect, or in our case, we use Zookeeper a lot, and we say we want to tell the web server where the database server is, where the current database master is, and where the database slaves are, and where the memcache servers are. That data might change day in and day out as we boot up or shut down machines, and so that's something we didn't go into a lot here, but we have some plugins in Puppet that will go out to Zookeeper and get that data, because that's not code in my mind. That is state data. It's operational state. It's how the infrastructure looks right now, and that's something that most of the time our engineers don't have to look at all. It's handled somewhat automatically in the background. So that doesn't quite go to your point, but I think those three things are important to differentiate.
So we're going to wrap the session here because we do need to get the next presenter in and set up. So Matt, can you stay for a few minutes and answer a few questions
I'm
for
happy to
folks
stay
afterwards?
and
Okay.
answer any questions.
Okay, great. Please get your surveys filled out. We sure appreciate everybody joining us today. Get ready for your next 2 sessions, and hopefully we'll see you tonight also at our reception at the Gansevoort. If you don't have an invitation for that yet, please see us out at the desk. We'll make sure you have one. Thank you.